So the next effect shot that we're going to do with Bifrost is ocean waves crashing on our shoreline. The setup for this is actually relatively similar to what we did in the first shot. We're going to create a pool and we're going to have a Bifrost liquid inside of that pool, and objects are going to interact with it. So let's go ahead and walk through that process really quickly of setting this up one more time. So we'll go ahead and we'll turn on our collision object and we'll turn off the display of that. So we're going to take this piece of geometry right here and we're going to create a Bifrost liquid from it. So we'll say create liquid. We're going to go ahead and change the voxel size to make it a little bit smaller by putting that down to a value of 1.5. It's going to increase the resolution of my particles and make them fit where we need them to be. We're going to add a couple collision objects to it. So this object has a little bit of the beach as well as this background pool. So we're going to create our first collision object. We'll jump over to our outliner and we're going to grab the animated Sven character. So we'll get this dude. We'll add him into our selection as into our Bifrost sim as another collider. And the last thing that I want to do is I want to add a kill plane. So what a kill plane is going to do is it's going to take any particles that might escape from like this crack here, or maybe this crack over here that would then start dropping down, and make sure that they don't just keep adding voxels to my simulation that I wouldn't ever see. So it's going to just make my simulation a little bit more pure and clean. So we'll go ahead and we'll grab a kill plane and put that on this piece of geometry. Now I'm positioning this kill plane and I actually can't see it. So we're going to go ahead and say show all so that I can see where that kill plane is. We'll drop this guy down right below where that container is, a little bit like that. So any particle that kind of falls out of this edge and starts to drop down into space, I know that kill plane is going to kind of clean that up and take care of that for me. So now I've got everything in my user interface displayed, which isn't really what I want. So we're going to just do a quick show none. And I'm going to go back and start toggling on the stuff I want to see. New in 2015 is the ability to hold the control key down and make multiple selections through these menu lists. So we're going to say polygons, we'll say fluids, and we'll say plug-in shapes to get the Bifrost in there. So we'll just close that guy down now. So with that done, what we're going to do is we're going to go ahead and just hide off the emitter shape. We don't need to see that anymore. We'll grab this node and we'll just send that off to Bifrost. So just like in the first example, Maya sends the data off to Bifrost, it queues it up, Bifrost picks the data and it starts processing it in the background, and we're already done about 20%. So as this is kind of coming online, I can just go to a frame where I might want to start fine-tuning my overall display of how these particles are moving. So we'll just jump to frame 59 or whatever. We'll jump into the shape node for this guy. We'll grab the particle information. We'll jump to color remap for that guy. Again, we'll drop this down to a low value, something like 4. Maybe we'll increase that particle size, kind of scrub through in here, and we can start to see our little dude is sort of splashing around just in this shallow water. And this looks cool, but it's not really the overall effect that I was going for. I really want kind of big waves kind of pushing on the shoreline here. So to do that, we're going to use something called an accelerator to add some influence to the overall speed of these particles in our liquid simulation. So accelerators are really pretty awesome. They speed particles up as long as they're within the influence range of the accelerator. So what we're going to do is we're going to create an animated piece of geometry with some wave pattern in it that we're then going to use to drive the Bifrost simulation. So let's go ahead and let that play in the background there. It looks like it's actually finished. So there's our character. So now we're going to go and add some more stuff to this to make it look a little bit more realistic. So let's jump back to our outliner here and grab our wave plane. So this is just a simple polygon object. I'm actually going to increase the resolution of this guy up to 100. And we're going to animate this using the new texture deformer. It's in 2015. So we'll bring this guy up and it does exactly what it sounds like. It allows you to take a texture and deform objects with it. What we're going to be doing is we're going to actually hijack the old alias ocean shader and use that to drive our texture deformer. Let's go ahead and increase the intensity of that texture deformer. We'll grab that guy and we'll just put the strength up to something like 10, and then we'll offset it by -10 to sort of get it back where it was, and we'll jump back into this ocean shader. So as I start to scrub my time here, you can see that ocean shader starts to have an overall effect on that textured piece, or on that piece of geometry. We can turn the turbulence down, and as soon as I do that, you're going to see that we're going to get this sort of nice rolling wave pattern coming toward our beach. So I'm going to just use a preset to kind of dial this in a little bit better. Have a little bit of noise on there on that guy. And what we want to do is we want to just have this time slider be driven with a simple expression. So I'm going to just say time is equal to my frame divided by 50 to slow it down a little bit. So time equal to frame divided by 50. So just hit enter, and just like that, we now have some animated waves deforming that piece of geometry. So it's kind of fun. We're hijacking some old tech inside of Maya, and we're going to use it to drive something very new and modern in Bifrost. So with that done, we're going to go ahead and take this piece of geometry, grab our Bifrost, and add that in as an accelerator. As soon as we do that on the shape node for that piece of geometry, we now have a Bifrost tab that we can kind of expand out, and you can see that we have some options for the accelerator. First thing we're going to do is change this from solid to shell, and then the next thing we're going to do is we're going to increase inherent velocity. So really what I wanted to do is I wanted to drive the speed of these particles based on the movement of that piece of geometry, and I'm going to overdrive that to a pretty high value, something like 5. I don't care about any directionality, so we're going to turn this stuff off. We want it just to get all of its movement inherited from the velocity of the actual movement of the deforming piece of geometry. So with that done, we can go ahead and take this guy, re-queue it back up. Bifrost is going to take that information and start processing it in the background. So as it's queuing up, I can begin working again. So Maya never really gets choked up. It never stops working. So we can go ahead and jump back over here. We don't really need to see that wave plane anymore. And you can see that this is already done about 20 frames. So we can just let this queue 100 frames. We don't need to do more than 100 of these guys. We'll kind of move back here to frame 20. And as I start to play through this time slider, you can start to get a sense of that water starting to actually get some movement introduced into it. So we'll jump back into the shape node for this guy, and we're just going to kind of spike that up so that you can really get a sense of where those white caps are. So notice how that water moves. We're just basically taking that texture deformed piece of geometry and using that to influence the speed of the particles or accelerate those particles. And as long as they're in contact with that accelerator, they'll continue to gain speed. So that's how we're going to get this sort of really nice little wave curl happening right here. Really amazing, amazing workflow. So one last thing that I want to show you with accelerators is the ability to paint color per vertex information to adjust the overall influence of that accelerator. So we'll kind of just let this scrub through a little bit more here, but really easy to get these very realistic looking waves. So let's go back to frame 1. We'll jump over here to our wave plane and we'll redisplay that guy. What I want to do is I want to use color per vertex information to adjust where this acceleration is going to happen. So if I right mouse click on top of this piece of geometry, go to Paint, Mesh, Color per Vertex, bring this guy up. Let's just double click on our tool here and change our value to white. I'm going to paint just a region over here. So this is going to be the only area that's going to be getting the acceleration. So we'll go ahead and we'll save that out. We can re-queue our sim. So again, as everything's working, re-queue the sim, now I can go back here and start cleaning up my display. I don't need to see that anymore. So if you highlight the node, you can see how many frames have been queued out and how many frames have been done. So if we jump back here to, actually we'll just let that do all 100 frames. If we jump back to frame 20, start to move this around, you can see that all of this area is really kind of quiet, not a lot of movement happening, but the area that's got that accelerator where the value was set to 1, it's still getting all that movement happening. So a couple of examples of how we can use accelerators to really influence the overall shape and feel of our Bifrost liquid simulation. So with that done, the next thing that we want to talk about is how we can go ahead and render all of these particles. A couple things that we can do. First thing that we're going to do is we're going to go ahead and get rid of this low-res sim and load up a higher-res sim, just like we did in the first example. So to do that, we'll go through the same process. We're going to go to Bifrost Options. I'm going to turn off background caching, and I'm going to turn off the scratch cache. We'll apply and close that. We'll jump into our attributes on the Bifrost container. We'll grab in a disk-based file. And for this one, we're going to go and grab a disk-based file that was rendered out at 0.05 also, or cached to disk at 0.05. So let's go ahead and jump to my drive. We'll grab the Sven Beach, kind of go down here to the beginning frame of 0.05. I should probably put these in a folder. I've got 0.1 and 0.05 in the same folder, so it makes it a little hard to find the first frame. So with that done, basically we now have a much higher resolution simulation. If we start to jump through this, we're still looking at the particles here, but we get a good sense of what's happening with the movement of that water. At any given time, I can also display the voxels, right? So instead of seeing the particles for this Bifrost shape, we could say, you know what? Show me what the voxelized surface looks like. The voxelized surface also has the ability to have its color display for velocity remapped, right? So we can drop this back down. So this is pretty cool, right? We're basically looking at the actual voxels that generate this Bifrost liquid, and Maya has the ability to actually render the voxels directly using the Bifrost liquid material. So what this means is we don't have to go through the process of meshing if we want to get a quick preview of what this object's going to look like when we render. Now this Bifrost liquid material also has the ability to generate foam based on the same attributes that the viewport 2 is generating this color remap. So we can query velocity and vorticity, which is sort of the churn of the water, and use that to drive the foam map. Now this first render that we're going to do, I'm going to leave the values set at a default range, and they're really not within the range of how fast this water is moving. So we're basically going to get just straight clear liquid. We'll render it off just so you can get a sense of what it looks like. So mental ray is starting to fill the buckets in now, and you get a pretty good representation of what this water looks like with the default settings based on the movement that this water currently has. And like I said, it's not really within the range of values that we want to have. If you look over at the min-max range over here, they're set to values of 8.5 and 120. And if you looked back at the viewport 2 display of the range that we were using to show velocity, it was in like the 0 to 3 range or 0 to 4 range. So we really need to recalibrate this foam remapping to better match what we were doing in viewport 2. So we'll go ahead and we'll save this image off. And we'll modify the range that the foam remapper is going to use to something like 0 to 3. Maybe we'll have a little bit of grayness added into that guy. We'll come down here and we'll spike that up, something sort of like that. Maybe have it kind of churn over it. And I might just drop. That looks pretty good. We could do a little diffuse remapping also, but I think this will look pretty good. So we'll go ahead and we'll save this out. I already did that, and we'll just re-render this. So here you can see that the water is actually coming in, and obviously there's a little bit of coloration that's been added to it based on the speed and the vorticity. The churn in the water, we're getting some white caps kicked up on the front leading edges of those waves. So we'll just flip between these two images, and you can really get a sense of what that foam generation is doing as it starts to kind of kick in there and add a little bit of white coloring on the areas that are moving a bit quicker. So rendering the ISO surface is all well and good, but sometimes you're going to want to have more control, and that's when you go through the process of actually meshing the particle system using the new Bifrost particle mesher. So let's go ahead and just look at that really quickly. We'll turn off the display of the voxels here. We'll drop down that particle display a good bit, and we'll just make those guys pretty small. So what we're going to do now is we're going to jump down to the meshing attributes, and we're just going to turn that guy on. So we have a lot of control inside of the mesher that allows us to adjust how the droplets are revealed. When we're meshing the surface, how tight are we going to hug the particles? All these different radius controls give us the ability to really fine-tune and tailor this mesh specifically to look the way we want. So once you go ahead and you mesh it, you could either render it directly inside of Maya, or you could export this out as an Alembic cache to save. The thing that's kind of cool about exporting this out as an Alembic cache is if you turn on the right color sets, which is right here, it's going to basically take the vorticity information as well as the velocity information and save that into the Alembic file. So what we're going to do is I'm just going to bring in a version of this cache that's actually been saved out with those same exact parameters, and we'll just re-import that guy back in. So we'll say Alembic cache, standard Alembic cache import. We'll jump back to my drive here, and we're going to grab the mid one, which is done at 0.15. So we'll open that guy up. And you can see that as soon as we bring that in, this mesh obviously is about the same resolution as the last one that we were just meshing, and all that color per vertex information is on the mesh to show us the speed at which this object's moving. This object also has the ability to show us the vorticity. So this is going to be the area that's got the highest churn inside of that. So just a couple of examples of how we can work with the meshes to get renders out obviously this information can then be passed along to extracted during render time to use in post, which is exactly how we ended up making the final movie. So the last thing that I want to talk about really quickly is bringing the data back in as a GPU cache. And this is actually really cool. So GPU caches are kind of a special flavor of an Alembic file inside of Maya. They load extremely quickly, and they basically bypass Maya's dependency graph and dump the data of the Alembic file directly to the GPU. So this lets us load massive data sets extremely quickly, and it also lets us play them back very, very fast. So if we go ahead and say show GPU caches, we'll just increase this, and you can see this is a much higher res mesh, right? This is a massive mesh that we just brought in. We'll load this up to 200 frames. We'll turn off the ambient occlusion, speed it up a little bit here, and we'll just play this back. So the first time through, it's going to basically take this information and it's going to be dumping it onto the GPU. So after it runs through the first time, it's loading it off disk right now, frame by frame. After it loads through, it's going to basically play back in real time, even though this is, again, a very, very high resolution mesh. And this is actually the mesh that was used to generate the final QuickTime movie that we're going to look at in just a second. So that's really cool. GPU caches with Alembic data coming off of the Bifrost meshed surface just looks amazing. All right, so let's go ahead and play back that QuickTime movie now so you can see what the end result looks like after we've extracted some of that velocity and vorticity information and used it in compositing. I'd like to thank everybody for taking the time to look at Maya 2015's implementation of Bifrost. It gives artists a very easy set of tools for creating amazing liquid effects.